Hello, my name is Neil Pickering and I'm a Chartered Occupational Hygienist and a Fellow of the Faculty of Occupational Hygiene of the British Occupational Hygiene Society. I'm also a Chartered member of IOSH and I'm currently a HS&E Director Consultant. I am here today to present to you some information on safety in welding on behalf of HSE&I and look forward to doing so. As part of this, I'm also going to talk to you about Do You Breathe Freely, which is the campaign for Breathe Freely in Manufacturing, which is focusing on welding. Breathe Freely in Manufacturing focuses on welding because of the combination of a significant hazard and a wide range and number of people potentially exposed to the welding fume and gases. We estimated that 190,000 workers undertake welding across the UK and Northern Ireland, ranging from those employed as welders and spending most of their time welding or preparing to weld, to those who do short amounts of welding for maintenance or for repair tasks. Some will be welding mild steel, while others will weld on stainless steel or more exotic alloys with varying toxicity of the metals involved. We'll consider these more later. The 150 cancer deaths that this document or information sheet provides may be from the more hazardous metals in the fume, or, as recent scientific evidence has now shown, exposure to general welding fume. The number is estimated from the HSE's data, and as I say, is for the UK as a whole. The campaign was launched in May 2017 by BOHS. The Breathe Freely 2 campaign follows on from one on construction, which is also ongoing as we speak. It was launched in London, and present at the launch from the left to right were at the time Karen Bufton, the BOHS president, Professor David Fishwick, the Chief Medical Officer at the Health and Safety Laboratory, Martin Temple, CBE, Chair of the HSE, and Dame Judith Hackett, Chair of what was at the time the EEF and is now Make UK. The Breathe Freely campaign aims to provide information to people that are the duty holders. So this is an example of what is on that website. Here we've got a picture showing controlling exposures to prevent occupational lung disease in manufacturing with lots of tools, fact sheets, guides, an introduction to welding and various other bits of information. As it says here, the information includes an introduction to welding, why do workers need protecting, for example, some information to help you to explain that for yourselves and also to other people. Some welding guides and fact sheets, a little bit on RPE guidance as well. And also a control selector tool for welding fume, which is a microsite that we've developed to help you to select the best control options. We'll take a look at that later. Of course, we're also very open to new ideas. So if you've got any ideas, please do send them into BOHS. You can find us easily on the website. Here's an example of a fact sheet, in this case explaining what exposure monitoring is and when it is needed. I'm not going to go through the detail. If you want to take a look, you are very welcome to do so. And here's a briefing for duty holders, so as you can better understand the hazards and risks, and as a call to action to get you to start taking improvement actions on the welding in your businesses. This slide takes a look at the likely and most significant components of the welding fume from various welding activities, which may come from the base metal or from the welding rod or the wire. The next slide shows us those of greatest concern. As you can see down the left-hand side here, we've got different types of materials that you might be welding on, and across the page, the brighter the colour, the more likely you will come across those particular components in the fume. So as we can see, low alloy steel, you might expect to get some chromium and some hexavalent chromium giving off. Hexavalent chromium in particular is toxic and has a very tight exposure limit. Also, you can see near the right hand side there, manganese, which has become very important for low alloy steel. We'll talk a little bit more about that later. This is based on the International Standards Organization's 15011, Health and Safety in Welding and Allied Processes. And these are the potential welding fume components of greatest concern based on the toxicity and the prevalence of the welding on the specified type of material. As I said on the previous page, chromium, hexavalent chromium, the chrome 6, chrome Vi, as it shows on the screen there, the manganese, and potentially the nickel. The workplace exposure limits for these components are tight or very tight and are likely to be exceeded unless effective controls are implemented. Following a change to the limits in August of 2018, the workplace exposure limits for manganese is now as restricted as hexavalent chromium because it is a respirable fraction that will apply to welding fume. This is particularly important for duty holders using metal inert gas on low alloy mild steel, because this often involves manganese in the welding consumable, the rod or the wire. Even though it may only form 1 to 2% in the consumable, manganese is more volatile and can be up to 10 times that proportion in the welding fume itself. Therefore, the tenfold reduction in the workplace exposure limit for manganese in August of 2018 makes effective control of exposures much more challenging than they were previously for MIG on low alloy steels. In other words, mild steel in particular. But it's no longer just certain components of welding fume that are identified as carcinogens. As a result of an extensive review by the International Agency for Research on Cancer, IARC, they reclassified all welding fume to be a Category 1 known human carcinogen for lung cancer in July 2018. There was also some evidence of a link to kidney cancer. As a result of that, the HSE put out some enforcement expectations. They concluded that the risk had changed so markedly that a safety alert was justified, and that was issued in February of 2019. That alert stated that the control of the cancer risk will require suitable engineering controls for all welding activities indoors, for example, local exhaust ventilation, LEV, which also controls exposure to manganese in mild steel for welding fume. Where LEV alone does not adequately control exposure, it should be supplemented by adequate and suitable respiratory protective equipment, RPE, to protect against the residual fume. Appropriate RPE should be provided for welding outdoors and should ensure that welders are suitably instructed and trained. Regardless of duration, the HSE will no longer accept any welding undertaken without any suitable exposure control measures in place, as there is no known level of safe exposure. And finally, that risk assessment should be updated accordingly. This aligns with the HSE Northern Ireland enforcement expectations, where they're very clear to say that the control of the cancer risk will require, again, suitable engineering controls for all welding activities indoors, e.g. the local exhaust ventilation we spoke about on the previous slide. Where LEV alone does not adequately control exposure, should be supplemented by adequate and suitable RPE to protect against the residual fume. To make sure that all engineering controls such as LEV are correctly used, suitably maintained, and are subject to thorough examination and test where required. To make sure suitable controls are provided for all welding activities, irrelevant of duration. This includes welding outdoors, and ensure the correct selection and use of any RPE. So, how do we go about controlling welding fume, which has clearly become much more important over the last few years? The hierarchy of control is shown here from the most effective at the top to the least effective at the bottom. There are often several controls required from different levels, and those different options are to eliminate, to modify the process, to apply local extraction, to change working practices, and last resort, respiratory protective equipment. So, to elimination. Is it possible to eliminate the welding entirely? Perhaps you can use other joining techniques, such as glue. Yes, even for metal-to-metal contact, that is an increasingly possible option. Or perhaps use friction welding or some other technique to join the two pieces of metal together, or design it differently so that you need less welding in the first place. That would all eliminate the need for at least some of the welding. Is it possible to modify the process? Perhaps instead of doing it manually, you bring in a robot to do some of the welding, particularly on repetitive jobs. That might be both an improvement in productivity, but also will reduce the exposures to employees while they're doing the welding. This is an example of stick and manual metal arc welding showing fume generation. As you can see, plenty of fume surrounding the welding visor of the welder as the process is underway. And it's a fume, the beauty of welding is you can see the fume when it's generated, particularly if there's a bright light, and often the bright light, the arc at the point of welding actually provides a light that enables you to see what the fume is doing. This is actually a graph from many years ago, but it shows the impact of changing the voltage, which can affect the current on the welding fume generation. The specific characteristics of fume generation will depend on the welding type, the job characteristics, the base metal, the consumables, and so on and so forth. Even the gas can make a difference. So the dip here that's shown in the welding fume generated at about 40 volts is illustrative rather than being definitive for every type of welding. However, it does show that by adjusting the welding parameters, you can actually reduce the amount of welding fume that's generated. Sometimes you might need expert support to determine that. Of course, the quality of the weld will always constrain the range of appropriate voltages that you can use. And you would certainly not want to have a poorer quality weld, because of course you'll need to do it again. There's also evidence to suggest that different welding wires result in different levels and mixes of fume, as does the wire flow rate, the shield gas used, and the pulse arrangement in the current. Unfortunately, again, these effects require some trial and error to assess the best options. But there are people out there, including the Welding Institute, TWI, that have undertaken tests for consumable suppliers and companies. And if you really want to take a look at that, may be able to assist. So we've looked at process modification. What about local extraction? Well, LEV has always been an important engineering control, but following the HSE alert, it is now mandatory for any duration of welding inside, and is also appropriate for welding outside where the conditions allow. Following slides provide some examples of what is possible, and also occasionally an example of what really isn't working. So here we have a well-positioned flexible arm extraction, an elephant's trunk if you like, with the welding fume being drawn away from the welder. Flexible arm extraction can be effective, but remember to highlight the limitations here with the operators. If they don't move it with the weld, or the weld has an extended bead, then it will not be effective. It really does need to be within roughly a diameter of the outlet or to the hood. So it really does need to be positioned close to the welding point, and also so as it's drawing the fume away from the welder rather than past the welder, because otherwise, of course, it's drawing the welding fume into the breathing zone of the welder before it gets extracted. So, as I say, flexible arm extraction can be effective, but it really does depend on the welder to position it effectively and to keep moving it to make it an appropriate control. We have here a video of a poorly located flexible arm extraction. It's above the welding and the fume therefore rises towards it, and it is captured, at least to a large extent. However, the welder is between the weld and the extraction, so all of the fume is drawn across the welder's breathing zone before being removed. When he moves to the top of the frame that is welding, the extraction system draws the fume more away from him. It's no longer between the two. And as you can see, most of the fume is captured because it's both closer to the welding point and directly above. Unfortunately, when he moves to the side, he's not moved the flexible arm with him, and the fume is now pretty much spreading out into the open atmosphere in the workshop. So as you can see, a flexible arm extraction really does depend on where you put it and where you put yourself when you're using it to be effective. So remember, it needs to be close to the welding point, above the welding point, so as the fume rises, it captures it more readily, or just behind it, and certainly without the welder between the welding point and the extraction system. Here we have a bench or booth type extraction with the welding fume drawn, as you can clearly see, to the back of the bench away from the welder. This requires sufficient air movement from the extraction to capture the fume, because the fume really wants to rise up and is being drawn back by the extraction system. But if you've got that right, this is a very effective way of doing welding fume capture. Of course, given the size of the booth or the bench, it is something that really can only be used for small to medium-sized components in most cases. Recently, there's been a lot of developments also of on-torch extraction. You may have tried them in the past and found them to be very clunky, very large, ergonomically of a poor design. Pleased to say that over the past few years, there's been some really good developments in this area. There are still poor ones out there, but there are some very good ones out there as well. Well worth trying if this is the best option for you in your situation. So this is an example of an on-torch extraction design with the nozzles close to the welding point to draw away the fume before it escapes into the general workshop. Care is required to set up welding gases flow rate on these and the extraction rate so the weld quality is not affected. If they're set up properly, they're very effective at capturing fume and do not affect the weld quality, but you do need to set it up carefully. You also need to be careful in corners because sometimes that can draw the gas away just a little bit more aggressively. Often they'll have a little switch, as you can see on the top here, that allows you to just open the gate up a little bit to reduce the flow before you then close it up as you move away from the corner. And so if set up correctly, and usually the suppliers of these bits of equipment will be more than happy to come and help you set it up, then they can be very effective at reducing the welding fume. They're not perfect, but they're good. Here we have an example of some welding. It's a video showing the welding with the on-torch extraction turned off. So you can see that the substantial welding fume is floating upwards, as you would expect, into the general workshop area. Clearly, no control at all since the extraction is turned off. But you can see a big difference if we then take a look at the extraction turned on. So there's much reduced welding fume both above the welding and around the arc. You can actually see the arc much more clearly in that case and the sparks coming out of it. So the welding fume is much more effectively controlled in that situation and very little was escaping. We have here an example of a welding shop. I must admit it's not a typical example of a welding shop. It's a very clean one, and I know that from past experience that welding shops aren't always quite this pristine in the way that they're set up, but nevertheless, you can see there are multiple flexible arm extractions that are all driven from a central system. That can be very effective if you've got a lot of different welding locations around the room, or you need to be able to put multiple flexible arms to a particular welding activity. But remember, as before, it's a flexible arm system. Whether it's from a central system or it's a one-off system, it still needs to be positioned in the correct place to be effective. And remember, the correct place was away from the welder, close to the welding activity, and not drawing the welding fume across the welder. Of course, to be effective, LEV has to be switched on and in good repair to actually achieve anything. This flexible arm here, which is just off to the right-hand side of the picture, is clearly switched off, or it has very poor flow because the fume is rising straight past it. Very little evidence that it's drawing the fume into it. So it has to be well maintained. You need to do the LEV checks, and of course you need to switch it on and position it correctly. So having looked at local exhaust ventilation, what about working practices? Well, working practices can involve a wide range of possible controls that will make incremental improvements. That can be down to the effective position of the LEV in informing people how to do that. Good welding technique to reduce the welding time and rework. If you've got very skilled welders, they should be able to do the weld much more quickly and they'll do it more effectively, so you don't need to go back to it as often. Effective maintenance and cleaning of the LEV, but also of the welding equipment and of course the respiratory protective equipment if you're using it. Daily and weekly checks to see that the extraction, RPE and any other controls that you've got in place are in good repair and clean. Information, instruction and training so that the welders and others know why they have controls and of course how to use them. The proximity of non-welders position relative to the welding, you know, for how long and whether they need additional protection. That could actually include supervisors. I've previously done some assessments in large engineering companies where they were doing a lot of welding, and the supervisors were walking around in amongst the welding most of their shift. And actually they were being exposed to a significant amount of welding fume, including the manganese that we've talked about previously. So an important thing to consider is other people that are working in and about the welding, even if they're not welding themselves. Shift work or extended working, so the exposures are for longer. You know, is that exposing people to more welding fume? And welding in confined or restricted spaces, so general ventilation is less, and you really need to pay particular attention to all of the hazards of the confined or restricted space, as well as the welding itself. Of course, you are using inert gases as well, so oxygen can be a challenge. RPE, we know this is a least preferred option in the hierarchy. It's very dependent on the welder to use and to keep it in good condition and working order. But it may be a necessary control, either if working outside, where extraction isn't reasonably practicable, or when welding inside if there's a residual risk from the more hazardous metals. One possible need for RPE is to protect welders against manganese fume from heavy, mild steel welding on large components with complex configurations. In such cases, the most likely extraction you're going to need to use, the only one that might be effective, is on-torch extraction. The video showed they were good, but they're not always able to capture all of the fume, particularly if you're working in different directions and configurations and different angles. In those cases, there might be sufficient residual manganese in the welding fume and the welding fume itself to require RPE as additional protection to the welder. A typical positive pressure welding respiratory protective equipment is integral with the welding visor, and this is shown here as a typical example. In this case, the air is supplied from a belt-mounted filter and fan, which also provides some cooling across the welder's face. And actually, you tend to find that welders are quite keen to wear this type of equipment because it does give them a cooling effect across the face while they're doing what is a hot job. Negative pressure RPE is not advised for prolonged use because they require more effort and they need to be fit tested and are less likely to be fitted and used correctly by the welder. So this, both from a likelihood that the welder will use it because they want to use it because it keeps them cool, but also it is much more effective to have this positive pressure integral with a welding visor. As I said previously, to help duty holders select and specify the correct extraction system for welding activity, a working group has developed a welding fume control selector tool on behalf of British Occupational Hygiene Society. We've designed it to be simple and easy to use so that a duty holder can understand and act on the results. And it's also, I'm pleased to say, absolutely free. Of course, you may find yourselves helping other duty holders, so let's take a look at the system. And let me first of all show you the best way to find it. So all I've done here is into a search engine, I've typed BOHS Welding Fume Selector Tool. The first thing that comes up is the Breathe Freely Welding Fume Control Selector Tool, which is what we need to take a look at. Okay, so let's try a live demonstration of the Breathe Freely Welding Fume Control Selector Tool. So here we are on the web page just here. I put in BOHS Welding Fume Control Selector Tool, and here we've got the link. So let's go to it. Straight in. As they say in the adverts, we're not shortening any of the links. So if it takes a long time, unfortunately, we'll see that it does, but it shouldn't do. So here we go, Welding Fume Control Selector Tool. It's part of the Breathe Freely campaign. I'll go into a little bit of the background to this when we go back to the presentation. Just remember that this is not a substitute for a full and properly conducted risk assessment, but it does give you some good advice in terms of the type of extraction systems that will work best for your particular circumstances. So here we go, launch the tool. And we're into the Welding Fume Control Selector Tool. It's going to ask some simple questions, which you will probably have the answers at your fingertips. They're not complicated, as we'll see in a moment, and then it'll give you some advice at the end. So what type of welding or cutting are you using? That is the first question they need to ask. So MIG, TIG, oxygas cutting, manual plasma cutting, manual metal arc, oxygas brazing, or arc air gouging. I'm going to pick MIG. I'm told that that is the most likely, and it's certainly the most likely across industry, I think. So let's pick MIG. Immediately goes on to the next question, which is, what material are you welding or cutting? So we've got a choice again here of aluminium, stainless steel, exotic metals, or mild steel. I'm going to pick mild steel because, again, that's the most likely that we've got out there in businesses. How long are you going to be MIG welding for? I'm going to say you're going to do this for more than an hour for the purposes of this demonstration. And the last question, how large is the workpiece that you're going to be working on? So we've got 4 choices here. Small, which is up to 0.5 meter by meter. Medium, which is up to 2 meters by 1 meter. Large, up to 2 by 4. And finally, extra large, more than 2 by 4. Let's start by looking at what we get if we pick medium. Okay. Straight away, we come through to the optimum control solution for your selections of MIG, mild steel, medium-sized component, and over an hour of welding, which is an extracted booth. We can download the PDF, or we can take a look at the document here. I'm going to just take a quick look at this document as it gets downloaded as a PDF. Here we go. So this is a Welding Selector Tool control sheet, fume extraction, extracted booth, and as we can see, it gives us a picture, so you know what one looks like. I suspect you all know what one looks like, but just in case, it gives an effectiveness rating, and this will come on to later, but takes account of both the capabilities of the extraction, but also the likelihood that it will be used appropriately. It gives a sense of the size of workpiece that it's useful for, some ideas around cost and other costs and filters that you might need to apply. So you've got some sense of the costs associated with ownership. Some information here on what an extracted booth is, and what some of the benefits and occasionally the downsides are to it. Some top tips on how to use it effectively. Some limitations. As it says here, mainly suitable for welding relatively small and flat workpieces. Some other considerations that you need to take into account, and potential alternative control solutions, because we recognise that it's not always the case that you can fit or use an extracted booth. There may be other reasons why this is not the best way forward for you, and it gives some alternative control solutions that might be appropriate in your circumstances. So, as I hope you can see, it's a simple sheet. There's just 2 pages. You can print this off, you can download it. It also has links to go to other parts of the Breathe Freely campaign, so as you can see, other advisory texts as well. We are trying to make this as simple as possible to pick up and work with. But if you've got any suggestions as to how to make it even better, then we are very open to those suggestions. Okay, so let's go back to the selector tool itself. I'm going to relaunch the tool now, and you can just click here to relaunch, and it takes us through to the start again. Okay, let's go back through it again. Again, let's go for MIG, because that's a regular type of welding that people use. Let's go for mild steel, because again, that's the most common approach that we might use. And let's go for over now, because we're dealing with welders here that are doing a consistent amount of work on welding. This time though, instead of medium, let's pick a large workpiece to see what difference that makes to the advice. You'll remember from the previous advice sheet that an extracted booth was suitable really for small and medium, so large will give us an alternative option. Okay, so the optimum control solution that is proposed for MIG welding on mild steel with a large component and duration of over an hour is an on-torch extraction, plus respiratory protective equipment, because as we know, on-torch extraction is not perfect. It can let 10%, even 20%, occasionally more than that, of the fume out, depending on exactly what the configuration of the welding and of the components. However, it is effective at taking at least some of the welding fume away. Again, we can have a look at the on-torch extraction document. Again, it's a short document just to set out the approach. So again, a picture, an effectiveness rating. You'll see that instead of being a 4.5 star, this one's a 4 star because it does rely a little bit more on the welder from using it correctly, although it is still something that is inherently able to do the extraction effectively. It talks here about small and medium, but it can be large and extra large as well. Supply and installation and other costs and filters. On-torch extraction, a little bit of a description here as to what it is. Some top tips on how to use it effectively, again, as we had before. Some limitations. Generally only suitable for MIG and MAG welding torches, and it needs to be located close to the welding area, as it says. Some research information and some other considerations to take account of. And finally, some alternative control solutions here. So extracted bench is suitable for small and medium. A flexible arm can be used, but is less likely to be as effective. So some examples there of other information that can help you to implement this effectively. And if you want to go back and take a look at another one, again, you can relaunch the tool. You can download the data sheets. We'd also click on the respiratory protection advice and so on. And you can also go and take a look at the Breathe Freely website itself. Okay, welcome back to the presentation part of this. So we've come out of the web pages and we're now going to just take a quick look at the team of volunteers that actually helped to create the Welding Fume Control Selector Tool. So this working group includes members from the British Occupational Hygiene Society, BOHS, and also representatives from the Health and Safety Executive, and has been endorsed by the HSE as an effective method of selecting the right control, and also by the HSE Northern Ireland. Starting at the back left, we have Andrew Kennedy, Mike Slater, John Saunders, Don Pocock, and Adrian Hurst. On the front row, we've got left to right, Dave Marsh, Adrian Paris, and Marion Malloy. Very much appreciate their efforts in creating this control selector tool. We had previously a look at a star rating. We saw that on the output that we got from 2 of the sheets that we looked at. So we decided that to help duty holders, we'd use a 5-star rating system, much in the way you might do for a hotel, to show real-world effectiveness of the extraction systems recommended by the tool. The overall rating is derived from the average of the 2 scores for the fume control system and for the user reliability. The system rating assumes an appropriately designed system, which is matched to the process, is in good working order, and has been set up to make sure that it's being used correctly. So that's a system element of the 5-star rating, and that is out of 5 as well. The user rating is then based on how much control the user actually has. So if the control is heavily dependent on the user, it will have a low reliability score. If it's fixed in the right position, it will have a high score. And obviously somewhere in between, it'll have a medium score. You probably already figured out that the flexible and movable arm or the elephant's trunk arrangement scores poorly on the user rating because it is so dependent on the user moving it to the right place. But if you've got a system that is well designed and you've got very little user input to it, the piece just goes into a suitable location within the system or in the right place in relation to the system, then you'll get a high rating for that as well, and you'll end up being close to a 5-star tool, which is actually what we saw for the extracted bench. The selector tool criteria is being set up as an online tool to help you make the right choice of welding fume control, and it asks the questions we've got here. Just a reminder, what type of welding or cutting is it? What type of metal is it? What size is the workpiece, and how workpiece, and how long will the welding take. The tool leads you through those and takes you to a data sheet which you can print off or view on the screen. The selector tool provides advice on the best available control solution for the task criteria selected by you, the user. It also provides links to other suitable alternative fume control solutions, as it's recognised that for one-off jobs, it may not always be possible to have the optimum control solution available. And with every fume control solution, there are limitations to its use and its ability to adequately capture fume, which are addressed on each of the control sheets as well, as we saw. Our intent was to develop a tool that was simple to use, but not simplistic in the information it provides, so that it's useful for you, the duty holder. I'm pleased to say that the selector tool has, as we said, previously been endorsed by the HSE and the HSE NI, and duty holders are frequently directed to it by them, and indeed by this video now. So, already showed you that you can put a simple search into it, BOHS, welding fume control selector tool, and it will come up immediately. We can also find it here on this website. And if you want to take a picture of the QR code, that should also take you to the right place. Do please feel free to go and have a look at it. You can use it on a mobile phone, you use it on a computer, and you should be able to use it on a tablet as well. It should work across all different systems, and it is free to use, as I've said before. Just like to remind you that this presentation is on behalf of the HSE Northern Ireland, but also shows you what the Breathe Freely campaign by BOHS is trying to do. It's trying to improve the worker control of exposure to substances that could cause occupational ill health, particularly for the lungs. So please do go take a look at breathefreely.org.uk and see what other information is there that might be useful to you. Thank you very much for your time and for watching this video. If you've got any further questions, please contact HSE NI via their website, via email, or the telephone number. Thank you.